Good day, grade 12s. Welcome to our mathematics revision for the final examination. We are continuing with questions based on sequence and series. The first question here says, consider the following sequence, which is 8, 18, 30, and 44. Grade 12, I've said it that for you to be confident working with sequences, just be sure that what type of sequence are you working with. So for you to do that, the first thing that you can do is just to do the differences. That is the difference between the first and the second term, and so on. So in this case, I'm going to say 18 minus 8. That is going to give me 10. And continue by saying 30 minus 18. That is going to give me 12. And 44 minus 30. That is going to give me 40. So in this case, I can just continue to calculate the second difference here, which is going to give me 2. The reason why I continue is because I can see that the first difference is not constant, so it may not be the arithmetic. Then this confidently I can say that is the quadratic sequence. Now, once we are sure of that, we can go on and answer our questions. Remember, you can also check if this sequence is geometric, and I believe by now grade 12 you know how to do that. Now, the first question says, write down the next two terms of the sequence if the pattern continues in the same way. Now, in this case, since we know that is what quadratic equation, we can see that our first difference is arithmetic, where when we add 2 to the next term, we get the next term. So in this case, adding 2 to 14, we're going to get 16, and adding 2 to 16, we're going to get 18. So you can just do that, and then add 16 to 44, and then you get 60. Then add 18 to 60, you get 78. That's how you get the next terms of your quadratic sequence. But now answering the question says write down. So it doesn't say calculate. It says write down the next two terms of the sequence. So you're only going to write your answers here, which is 60 and 78. And that's how you answer that question. Question 1.1.2, it says calculate the nth term of the sequence. We are confident that is the quadratic sequence, and we know that the general term is given as Tn is equals to an squared plus bn plus c. So we need to go on and find the values of a, b, and c. And we are told in our different schools that your a plus b plus c is equals to what? The first term of your sequence. And your 3a plus b is equals to the first term of the first differences, and your 2a is equals to the second difference. So that is how you're going to calculate the nth term of the sequence. Starting with a, we can say that 2a is equal to 2, and solving for a here, we need to divide both sides by 2, which I believe by now you know how to do. And then 2 divided by 2 is going to give us 1, so the value of a is 1. Then we move on to the ray a plus b, which is equals to the first term of the first differences, which is 10. In this case, then substituting a is 1, so you substitute a for 1 here. So we are going to have 3 times 1, which is 3. Let me just write it here. 3 times 1 is 3, because a is 1. Then that is plus b equals 10, and then you can subtract it on both sides. Then your b is going to be equals to 10 minus 3. In this case, going to give us 7. Now continuing to find the value of c, you're going to use a plus b plus c, and this is equal to the first term of the sequence, which is 8. Sorry, that is 8. Then let us sub in a. A is 1, b is 7. We don't have c, we are looking for c, and that is equals to 8. Then 1 plus 7 is 8. Then subtract 8 on both sides. Then your c here is going to be equals 0. So your c is 0 in this case. So we're going to sub it in our Tn formula. So a is 1, then we're going to have 1n squared, which you don't have to put the 1 there, plus b n, and your b is 7, that is going to be 7n, and your c is 0, so you don't have to write your 0 there. So that is going to be your general term, as they have requested you to do. Question 1.1.3. Which term of the sequence is 330? Which term of the sequence is 330? So grade 12, once they ask you which term of the sequence, they are looking for the position of this term, 330. Where is it in the sequence? So for us to be able to do that, it means we have to go and calculate the value of n, and that is going to be Tn. So your Tn, it is going to be 330. Let's rewrite the formula. Tn is equals to n squared plus 7n. So instead of Tn here, you're going to put 330, because we want to know where is this 330 in our sequence. Then we have to calculate n. So we leave n as it is here, plus 7, and also this n there. Now this looks like a quadratic equation, which needs to be written in the standard form. And writing it in a standard form, it means you take all the terms in one side, then you leave only 0 on the other side. So you're going to write it here as 7n, n squared plus 7n minus 330 equals 0. Don't worry, I've moved everything in one side and I've left 0 on the other side. Now grade 12, I know most of us, we've got a problem of factorizing and we all run to the quadratic equation. But since you have got your Casio silver calculator, even your calculator can do your factorization for you. You can just press your setup and choose equation, and I think you choose option 3 for the quadratic equation. Then you only insert the coefficients. You're going to insert 1 for A, you're going to insert 7 for B, and insert negative 330 for C. And then you just press your equal sign twice, then you get the values of the factors actually of 330. So in this case, your factors are going to be 22 and negative 15. So in this case, our n is equals to negative 22, or our n is equals to 15. So grade 12, since we know that we are looking for the term number, which term of the sequence, which cannot be negative, because we find this value by counting, so we cannot count the negatives. So our 22 here, negative 22 is not going to be valid, but the only answer that is going to be valid is your 15. So therefore you say n is equals to 15, and it is so imperative for you to make this conclusion, because only one of these values is valid, and that's how you answer that question. Now the next question says, it is given that the general term of the quadratic number pattern is Tn equals n squared plus bn plus 9, and the first term of the first differences is 7. Grade 12, that is something that you should be able to note. Very, very important. The first term of the first differences is 7. Remember that the first difference is equals what? Equals your 3a plus b. So that is how you're going to answer this question here. Your first difference equals 3a plus b. So you're going to have to say 3a plus b equals 7. Then from the general term that is given here, we can see that the coefficient of a here is basically 1. So we come back and substitute our value of a here. We're going to have 3 times 1, which is 3. So you're going to have 3 plus b equals 7. Therefore, you can say that your b is equals to, by subtracting 3 on both sides, then you're going to have your b being equals to 4. 7 minus 3, that is going to be 4. And that's how you answer that question. Question 1.2.2. It says, determine the value of the 60th term of the number pattern. So let us go on and answer it here, right on along the side. So for us to be able to do that, we should have our general term with b being substituted. So that is what we're going to do here. Your Tn is equals to n squared, then we sub b 4 for 4. So we're going to have 4n plus 9. Then we can now calculate the 60th term by substituting 60 for every term that we have here. So that is going to be T60 is equals to 60 squared plus 4 into 60, then plus 9. Then your 60 squared, that is 3,600. 4 times 60, that is 240 plus 9. That is 3,600 plus that is 3,849. Yes, and that's how you answer that question. Then the next question, 1.2.3. It says determine the general term of the sequence of the first differences of the quadratic number pattern. Write your answer in the form TP is equals to MP plus Q. We are so used to having our general term for the first differences as Tn is equals to what do we have? Is it Bn plus C? So sometimes we normally use Bn plus C. So in this case, they say that we should write it in that form. Okay, grade 12. For us to be able to do that, nonetheless, we need to have our sequence, the quadratic number pattern sequence. And how do we do that? We substitute the, okay, let's do the first one here. We're not going to do all of them. I'm just going to do the first one. This is going to calculate the first term of your quadratic number pattern. So that is why I put T1 here, the first term, T1. So for every n, I'm going to put 1 here. So that is n squared plus 4 into 1 plus 9. 1 squared plus 4 plus 9, and that is going to be 14. Yes, so that is going to be our first term. So you can go on and substitute T2, T3, T4, and yeah. Let us at least have 4 terms for the quadratic number pattern so that we can have at least 3 differences. So 14 is going to be our first term here. When you substitute 2 in here, you're going to get 21. Then you substitute 3, you get 30. Then you substitute 4, you get 41. Then let us go on and calculate our first differences. 21 minus 14, that is going to give us 7. 30 minus 21, that is going to give us 9. And 41 minus 30, that is going to give us 11. And then we can see that we've got our nice arithmetic pattern there, with the second difference of 9 minus 7, which is 2, and 11 minus 9, which is also 2. Nice. So that is what we have here. So for us to be able to calculate or to determine the general term of the first difference, we know that from this formula that I've written here, the general term here, we know that b plus c is equal to the first term of your first difference. But in this case, we don't have b plus c because we are told to calculate it in this format. So instead of b here, we're going to have m. M is going to be equals to what? The second difference. So instead of having b plus c, we're going to have m plus q. And that is going to be equals to what? The first term of the first difference, which is 7 in this case. So that is how we have it here. So we're going to substitute m for 2 because m is equal to 2. So that is going to be 2 plus q equals 7. Then you can subtract 2 on both sides. Therefore, your q is going to be equal to 7 minus 2, which is 5. Then your general term is going to be Tp is equals to, your m is 2p, and your q is 5. And that's how you answer that question. I hope you understand that. Now, question 1.2.4, it says which consecutive terms, let me take off this here so that it's clear, which consecutive which two consecutive terms in the quadratic number pattern have the first difference of 157. So you should know that the first difference is what we have here as our arithmetic sequence here. So they're asking you which two numbers, when you subtract them, they give you that value. Grade 12, if I can ask you, which two numbers do I subtract in this quadratic number pattern so that I can have 7 as my first difference? So it's term number 1, which is 14, and term number 2. But how do you get the difference? It's always t2 minus t1, or the next term minus the previous one. So if I can find out what is the position of 7 in my arithmetic sequence, then I can safely say which two numbers I can subtract for me to get 7, which is 21 minus 40. So why don't you just go on and calculate what position is 157? So we already know that 157 is a term in the first difference, and fortunately we do have the general term for the first difference, which is this one here, tp is equal to 2p plus 5. So okay, let's write it here. Our first difference general term is 2p plus 5, and let us go on and find out what is the position of this term 157 in our first difference. So it means we're going to calculate what p, because p here represents n, remember, p represents n, so we're going to calculate the value of p. So how do you do that? You can subtract 5 on both sides, then you're going to have your 2p being equals to 152. Then you divide by 2 on both sides, and then you get what? Your p being equals to, when you divide by 2, you get 76. So 157, it is in the position 76 in the first difference, which is the arithmetic sequence. So that's where it is. So remember, how do you calculate the two numbers that are giving you that? It is always the next term subtract the previous one. So here we've got the previous term or the current term. So it means your 157 is going to be between what? This current term, because it's always the current term t number 76 in this case, and the next term, because it's always between the two terms which are consecutive. So for you to find out what is the value of 157 here, so that is going to be term number 77 subtract term number 76, and that is going to give you 157. And that's how you answer that question. 1.3. The first term of the geometric series is 14 and the sixth term is 448. Then the first question says calculate the value of the constant ratio. The constant ratio, which is r. We're basically calculating r here, the constant ratio. Now let us look at what is given. We are given the first term, which is a. Let's write down what is given. We are given a, that is 14, and we are given the sixth term, which is t6, and we are told that is a geometric series. So we can express t6 with the geometric series formula. That is going to be what? That is t6, which is here is supposed to be n minus 1, and our n is 6, so that is 6 minus 1, which is 5, and that is equals to what? 448. You cannot tell me you don't know how to express this grade 12 by now. You should be able to express that. So this is what we're going to use basically for us to be able to calculate the value of r. That is what we're going to use. So we're going to say t6, which is what? 448, because it is given there as 448, is equals to, it is supposed to be ar to the exponent 5, but our a is 14. We are substituting here. A is 14, then r to the exponent 5. Then the next thing is to isolate r to the exponent 5 by doing what? By dividing by 14 on both sides. So you divide the right hand side by 14, they're going to cancel out, then you'll be left with r to the exponent 5. Then when you divide the left hand side to 14, you get what? 448 divided by 14, you get 32. Now since here r is the base of the exponent, it means you also have to express this as the base and the exponent. You can just use a calculator to do that. Just press 32, then press the equal sign, press shift, then press fact. Then it's going to give you what? 2 to the exponent 5. 2 to the exponent 5 equals r to the exponent 5. So you can see that the exponents are equal here, therefore the bases are also equal. So which means your r is going to be equals to 2. And that's how you answer that question. Moving on to the next question. Question 1.3.2. It says determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain the sum of 114,676. Now grade 12s. Questions like this. You need to read that and make sure that you understand what the examiner is exactly asking you to do. Don't read it once and say you understand. No, these questions, I know most learners makes a lot of mistakes. But anyway, let us look at what the examiner is requiring us to do here by reading this question again. Determine the number of consecutive terms. The most important thing, the number of consecutive terms. Now it means here these numbers are following each other, and these numbers must be added. Added to where? To the first 6 terms. They must be added to the first 6 terms. Now, what do you think of when you talk about numbers, consecutive numbers that are being added? You think of the sum. You think of what? Of the sum. And then what type of sequence are we working with here? We're working with this geometric sequence. So we're going to go on and write the sum formula for the geometric sequence, because the examiner requires us to find the consecutive terms that are added. So that is going to be a r to the exponent n subtract 1 divided by r subtract 1. Now, there are two ways of doing this. You can just use the sum of this number, or for this number as it is given. But if you're going to use this number here, it's going to give you all the consecutive numbers that are added to get this number. All the consecutive numbers that need to be added to get this number. And we already have got 6 numbers that are there. So it means from that sum, the total number of terms, you're going to subtract 6, and you're going to be left with the consecutive terms that the examiner is requiring us to calculate. So let us go on and do it here. So we're going to have what? 114,674 equals, the first term is 14. Our r was just calculated there as 2, and n is what we are looking for. Remember, your n represent the number of terms. Then that is divided by 2, subtract 1. Then 2 subtract 1 is basically 1. So you can see that is 2 minus 1. I'm going to remove it here because 2 minus 1 is 1. Then you don't have to divide by 1. So basically our equation is like this. So we can go on and divide both sides by 14. When you divide on the left hand side by 14, how much do we get? We're going to get 8,191. When you divide on the right hand side by 14, 14 and 14, they are going to cancel, because that is our aim, to remove this 14. So we are going to be left with what? 2 to the exponent n minus 1. Therefore, you can add 1 on both sides, so that you are left with 2n on the right hand side. When you add 1 on the right hand side, minus 1 and 1, they cancel. Then you add 1 on the right hand side, you get 8,192. So in this case, grade 12, you can use a trial and error, or basically you can just use your log. You can convert this to logs, and I believe that everyone knows how to do that by now. Everyone knows how to convert to logs. Your exponent becomes your subject of the formula, then log, the base remains the base, which is 2, and your number comes here, 8192. Then you just use your calculator there. Therefore your n is going to be equals to 13. Then, as I said before, because we used this number, which is the total number of terms that must be added, these are the total number of terms that must be added here. But we were adding this number to 6 terms that are already there. So it means we have to subtract 6 terms, because this number here includes the 6 terms that are the number of the 6 terms that are already there. So we're going to say that from the 13 here, we're going to subtract 6. Then it means your n is going to be equals to 7. Therefore, we can conclude that only 7 more terms must be added. 7 more terms must be added. Right. Then the next question, I hope you do understand it. The next question, 1.3.3, it says if the first term of another series, another one now, is 400 48. Now we're working with, let's do it here. Let's make it as we're going to do it just right there. The first term of this series is what is, let's write down, make it a point that you make it a habit, actually not a point, make it a habit that you always write the data that is given to you, so that you'll be knowing what you're working with on different stages of you answering questions. Now we're working with our A in this case is 448, but our sixth term is 14. So T6 is 14 here in this case. Now the question says calculate the sum to infinity. Oh yeah, we're working with the geometric series anyway. I was expecting that we'll be asked to calculate the sum to infinity. So for you to calculate the sum infinity, as we know, the formula says what? Sum to infinity equals a divided by 1 minus r. So for you to do that, you need two things. You need a and r. So we've got a here. How do you find the value of r? We're going to use this information here, that T6 is 14. So remember that we can express that your T6 can be expressed as a r to the exponent 5. But the T6 is 14. So that is 14 equals your first time, which is 448, then r to the exponent 5. Then in this case, you can divide both sides by 448. You use your calculator there and remove the 5 there. Then your r is going to be equals to 1 over 2. You can quickly do that and come back here and substitute. So your a is 448 divided by 1 minus your r, which is half. Therefore, your sum to infinity is equals to, using a calculator, okay, that is going to be twice the number anyway. So that is 896. And that's how you do that. I've added this question out of interest. It looks so interesting. It says if the sum of that expression is equals to 21 over 6, determine the value of k. So here we starting off with p equals 0 and ending at k. That's what this expression says to us. So what you need to do here, grade 12, just to make sure that you calculate the first 3 times of the sequence. Let us go on and do that anyway. Let us calculate the first 3 times of the sequence, so that we will be knowing what type of sequence are we working with. So the first term, we're going to go to our expression, which is 1 over 3p plus 1 over 6. But our p here, we started 0, so we're going to substitute 0 here for p, plus 1 over 6, and anything multiplied by 0 is 0, so that is out. The first term is going to be equals to what? 1 over 6. And then going to the next term, term number 2, we started substituting 0, so we increase that by 1. So 0 plus 1 is 1, so we substitute 1, and that is 1 over 6 equals to, when you multiply those together, they give you what? That is 30 over 6. So that can be simplified, but let us leave it as it is, as 30 over 6, because the previous term is also over 6. Then we're going to get our next term by increasing the previous one that we substituted by 1. So previously we substituted 1, so increase 1 by 2, and that is going to give you 5 over 6, and that is your series. 1 over 6, 30 over 6, that's 5 over 6. Now here you can get your common difference, or you can get your constant ratio. Let us first do the common difference. by saying t2 minus t1. Let me write it here first. T2 minus t1, and that should be equals to t3 subtract t2. So t2 is 3 over 6 minus t1, which is 1 over 6. So 3 minus 2 is going to give me a 2 over 6, which is 1 over 3. Then coming here, t3, that is 5 over 6, subtract 3 over 6. 5 minus 3 is 2, 2 over 6 is 1 over 3. So clearly here we can see that we are working with what? The arithmetic sequence, and that has given us the constant ratio. So since we are working with the sum here, we are going to write down the sum formula for the arithmetic, which you know very well. Your Sn is equals to n over 2 all into 2a, right? That's 2a plus n minus 1 and multiply by d. So that's what you have there. So we are told that the sum there equals 21 over 6. So we can just write our 21 over 6. That is our Sn basically. 21 over 6 equals to, we are looking for n. Our n here is going to represent k. So we are looking for n here. N over 2 into 2. Our first term is 1 over 6. Plus n minus 1, then our d is 1 over 3. So that's what you have there. How do we simplify this? You can first multiply each term, multiply the left hand side and the right hand side by 2 so that you can remove this 2 here. So when you multiply both sides by 2 here, we're going to get, just use a calculator here, 21 over 6 multiplied by 2, it gives us 121 over 3. Then you'll be left with n, because the 2's will cancel and simplify inside the brackets. So inside the brackets, 2 multiplied by 1 over 6, it gives us 1 over 3, and that is plus n times 1 over 3, that is 1 over 3n, and you've got the negative sign there. So negative 1 times 1 over 3 is negative 1 over 3, and that's what we have now. So you can simplify inside the brackets, 1 over 3 and 1 over 3. You can see that they're going to cancel each other here, because it's 1 over 3 and minus 1 over 3. You'll be left with n multiplied by 1 over 3n. So that is going to give you, just multiply n and n, that is going to give you n squared. So you're left with 121 on the left hand side over 3. Then you can multiply both sides by 3 so that you can remove your denominators. Then you're going to be left with 121 equals n squared. Then you get the square root of 121. Therefore your n is going to be equals to 11. Someone can say that since we use the square and the square root here, you always get the plus and minus. But remember, we are calculating the number of terms, and the number of terms cannot be negative. But remember that for you to calculate the value of k, you're going to say that the number of terms, which is 11, how do we calculate the number of terms? We always say that the top minus the bottom, which is k, plus 1, right? And k minus 0 is k, then you subtract 1 on both sides, therefore your k is going to be equals to 10. And that's how you simply do that.